this is me, Melinda Hahn-Williams, Chief Data Scientist. So Distillery is a custom audience solutions company. We do custom AI targeting to help advertisers figure out where to show their ads online. And a big focus for us right now is ID-free targeting, which is a way to show ads without any IDs on the user. And today, I'm going to talk about a challenge that every AI company faces around how to enable innovation. And that is, how do you bring an idea from prototype to production? So this is an engineering challenge, but it's not just an engineering challenge. So this really ties into how you structure your teams, even how your culture around developing new products and continuously learning and improving all ties together. And so I'll share how we solved this problem at Distillery by building a flexible machine learning platform on Google Cloud. So I'll share how we did that. And I'll share some specific examples of really innovative AI that we built on that platform. So in building this flexible machine learning platform, I learned that the culture of how you think about your products can really grow from your engineering architecture. And so I'll share how at Distillery, as we built this, or using this flexible machine learning platform, it's really strengthened our culture around faster development, continuous improvement and iteration, and unlocked our innovation. So the challenge, how to build innovative production-grade AI products, how to bring them to production. And specifically for us, we're in the digital ad space. I think everyone knows that there's been an increasing movement towards privacy in digital advertising. There's a lot of forces at play here, but a sort of pivotal moment in this story was in 2020 when Google Chrome announced that they were going to be retiring third-party cookies. Meanwhile, alongside of this, there's been explosions in machine learning, as I'm sure you also all know. This is a picture of a robot learning that I made on DALL-E. But this kind of generative AI that we're all hearing about right now, that's not really the explosion that I'm talking about that's super useful to us. What I'm talking about is really the type of AI that's like one layer beneath that. So when you think about hearing about AI that can go like read the internet and learn English that way, like that's the type of learning I'm thinking about. Because that type of machine learning, it turns out, is really good at doing more with less data. And that's exactly the problem we're trying to solve, right? We want to do effective targeting in a situation where there's less and less data available. Did I not have my robot up there before?
No, you did.
Oh, OK, cool. I'm not pointing this in the right spot. OK, so in 2020, when Google broke the news that they planned to stop supporting third-party cookies, we already had a product developed. We already had this type of machine learning applied to that problem, and something that we call ID-free targeting, how to target ads without any user information at all. And what we had was a prototype, a research prototype. So we needed to bring that prototype into production. And bringing a prototype to production is something like taking a home recipe for cupcakes and making it into a Hostess factory. So it's not a small task. We knew that we had to do it for ID-free, but we didn't just want to do it once. We didn't just want to build this one application. We wanted to build a new way of making machine learning applications, because we knew that we're in a space that's changing, the problem is changing, the technology is also changing, and we wanted to be able to build any kind of machine learning application in the future. So we need a new way to build machine learning applications that's going to let us go faster and improve more and really unlock our innovation. OK, so why do I say we need a new way? Let's take a look for a second at kind of the classic approach. So this is like a purpose-built application. It's got all its pieces nice and clean and all tied together. But this is purpose-built. It's built to do a certain type of algorithm on a certain type of data for a certain purpose. And so it's kind of like one of these old school lecture halls where the chairs are like bolted to the floor. And it is awesome for lectures, but you're not going to do much else. If you want to do a chemistry experiment or you want to play indoor soccer, like you would really have to rip out and rebuild the whole thing. And so we want something that supports more flexibility so we can be more innovative and do more things. So does anyone know what this is? Any Harry Potter fans in the room? It is at Hogwarts. Any guesses? This is the room of requirement. So this is in the Hogwarts castle, and it is whatever you want it to be, whatever you need it to be. It can serve that purpose. So we need a room of requirement, right? So our goal is to create a way that we can quickly produce any type of machine learning algorithm. Okay, so this may sound like it's completely unrelated to engineering architecture, but actually how you build your teams is completely intertwined with how you structure your systems and how you build your software. So to build a machine learning application, you need all these different skills, right? You need someone who comes up with totally novel machine learning solutions to a business problem. You need people who can design a super robust industrial grade engineering system, all this different stuff. So one approach to doing this is to look for generalists that can kind of check all the boxes. The kind of opposing approach would be to split this up into two specialties. I'll call them DS researcher, who comes up with the new ideas, and the machine learning engineer who puts that thing into production. So this comes with some hazards to this kind of specialization. The main one is around that handoff between the researcher and the engineer. So this is a translation step, so there's always something lost in translation. It tends to kind of become one way where things get hardened once they move over to production. And then it just takes time, right? So we want to avoid this step. But specialization also has a huge advantage, which is that it's the best way to hire the most awesome people, right? And at Distillery, I'm just not willing to give up access to the most awesome people in either of these specialties. Like for our business, we need industrial grade engineering. We need the most novel machine learning applications. So it's sort of, I really need to go the specialist route. But we do have this handoff problem, right? So how are we going to support that? So this is where engineering architecture solves a staffing problem, right? So this is going to become another goal for our system. We want to have a way where you can avoid that handoff problem and put something very close to what the researchers are making into production without like a messy handoff. Okay, so our solution, we built a flexible machine learning platform. We call it ML Pipes. And so, okay, how do you build a flexible machine learning platform that lets you get stuff to production faster, anything you want, and avoids that handoff? So to talk about how to build a platform, first I do need to take you through like what are the pieces of a machine learning application, of one application in the first place. So there's really like, it's made of really three things. The first thing is the core machine learning code. So this is basically what the research prototype is made of. And then the other two parts are the parts that make it into a robust engineering system. So you have your orchestration, the logic of what to run when, and you have what I'll call glue code, like all of the connectors that kind of just like make everything work. And so in a purpose-built application like this, the orchestration and the glue code is all kind of connected, all kind of bound up in the machine learning code and really written specifically for that one use case. And of course, we want flexibility. We want to be able to build a new application without having to rewrite all of that stuff from scratch every single time. So what we're looking for is not like a circuit board where all of the components are soldered into place and the connectors are printed on the board. What we want is a breadboard where you have these universal connectors. You can just plug your components into them and it just works. Okay, so how do you build a machine learning breadboard? So first, we pull the orchestration out into its own layer. And in this layer, this is where we run the step that has that information about what to do when. So there's something really cool and really important in this slide, which is, so far I've been showing this diagram of this application, and it's meant like the entire application with all of the parts of it built and wired together. But here, this is not the application. This is just the instructions for how to run the application. And I put just that part here. And then the orchestration layer calls out to the data preparation layer. And that's in the data preparation layer. Here we're running the code, again, specific to this application. So that's the process graph for ID-free. We're running the code to collect the data for ID-free. We collect the data, we put it here. Then the orchestration layer calls out to the machine learning layer. And here's where we run the ID-free specific machine learning code for this process. It kicks off its own little pipeline and does all the machine learning steps. And it pulls from that same data, and then you run that algorithm, and you output the result. Okay, so check this out. This is the cool part. all the stuff in green, this is all specific to ID-free, right? All this one application that we built. If I pull out all the stuff in green, maybe, if I pull out all the stuff in green, I am left with all of this reusable glue code, right? All of the connectors. And this is like all those universal connectors. So what I have now is a machine learning breadboard. And I can take this machine learning breadboard and plug in a completely separate application. So in this case, this is our map of the internet, which I'll talk about a bit in a little bit. I'll talk about that in a bit. So we can plug in the map of the internet code, and now this just works. We have an industrial grade application. We didn't have to start from scratch and make all of those connectors. We can just plug that in, and that works. So a little bit, because of where we are, a little bit about how we made this. So the substrate for this whole thing is Google Cloud Platform. I won't name like every single component, but some key ones. We have Cloud Composer doing the orchestration. The data preparation is on Dataproc. And then we have Google Kubernetes Engine for the machine learning. And usually when you make a diagram like this, like a tech stack diagram, you end up with all these cute little icons with all like animals and all different colors and stuff. And so I was a little surprised when I made this, and I was like, oh, I just made a Google ad. But while we're here, I'll just call it a couple of advantages in running this way. So this is actually the first cloud native application thing we've done in Distillery. We've been in the process of migrating to the cloud, and this is the first thing we've built specifically in the cloud. And so there's some really cool things about running this way. One is that all of these individual layers, you can just spin them up really easily. And if you don't have to mess with any hardware, obviously. But a cool part about that is if I needed to spin up a whole nother instance of that, it's like really straightforward to do that. The really cool thing is that is the scalability. So the Dataproc and the GKE, where the data preparation and the machine learning are running, those things can all easily be set to just scale based on load. And that's especially cool. Like us, we're talking about a new product. So as demand increases for that product, it's like a complete non-issue. We just scale up the clusters and we can just support that load. And this is like completely different from life on-prem. So this is very cool. Oh, another thing we used. So this changes, this ML Pipes, this flexible machine learning platform, yes, it changes how we develop machine learning applications. It also changes how we work. So here's a couple ways it does that. So first, faster development. So we're talking about weeks instead of months for a new application, which is obviously cool. You save engineering time, and that saves money, so that's great. But there's some benefits to this that are even more exciting than saving money. So first, it's faster development means there's a lower barrier to building new products, new applications. And so that means you can place more bets, you can try more things. And then faster development means you can get things into market faster, you can get feedback faster, you can iterate faster, you can reject things faster. And so everything just happens faster, you can have ideas faster. So this alone would be enough reason to build this platform. But I think there's actually even better reasons that we found. So continuous improvement. So we got rid of that handoff, right? We have essentially the research code with very few modifications running directly into production. So now it is so easy to make changes in production. And making it this easy to make those changes really creates a culture where people are making those changes all the time, making improvements, looking at what's happening, seeing how you can make it better. And this is real at Distillery. So we have now on a regular basis researchers making pull requests, so requests to change the production code on a regular basis. And then I think the most exciting one is it just unlocks innovation. So ML Pipes is like a blank slate. We can run any machine learning application we want. It's just our creativity as the limit. And so the big thing that's really done is now we're entertaining ideas that before just would have seemed too prohibitive to implement, to even bother with. So there's a lower barrier to making new things, even if what you're making might not work. And that's really where innovation comes from. OK, so I'm going to show you a couple of the really cool things we made on ML Pipes. first, our solution to that digital advertising problem of how do you target the ad with an environment where there's signal loss. And so the way we approach this problem, we stop trying to figure anything out about this user, and we focus on the impression itself, that piece of ad inventory. So we need to find out as much as possible about that impression, understand that website as well as we can. And we do that through behavioral signals. So we look at opt-in panels, digital panels, where people have opted in to share their web browsing history. So picture like a browser extension. And so we're looking at millions of these sequences of website visits. We use this all to train a neural network, and what we get is a cloud of dots. And this cloud of dots is a 128-dimensional map of the internet. So every website has a spot on this map, and its coordinate in 128 dimensions tells you a ton of information about its association, how it's associated with every other website on the internet, in terms of the actual real-life behavior of how people use that website. So to give you an idea of what that looks like, I'm going to zoom in on this little box. So here, every dot is a website. Dots that are in basically the same spot as each other are websites that are about basically the same thing and visited basically interchangeably. And then websites that are in a kind of a near spot are about kind of the same thing. And so the real power here is we have an understanding for every website on the internet of exactly how it's related to every other website on the internet in high enough dimensionality that you can kind of capture all of the different ways that all these different websites could be related to each other. So this is a super powerful foundational thing that we then use to build a lot of our machine learning applications. In particular, ID-free custom AI, which we proudly show our new registered trademark. We just got that this year. So now this becomes another machine learning layer that happens on top of that map of the internet, where we now figure out for a specific advertiser exactly how valuable is each impression to that advertiser. Oh, and it works really well. So if you compare it to like the classic ID-based version where you have that user's full history, this comes in just a little bit behind that in terms of performance without that information, so it works super well. So those are just two applications that we've built on MLPipes. And I'll add that both of those applications, by the way, were originated and led by our head of DS research, Amelia White, who's here today, so make sure you talk to her afterwards. And so what's next? I won't share the details of what we're working on next. I'll just say that we're doing a lot more deep learning. We're going a lot more places that we haven't been before. And I'm dying to tell you where I got this image, so you can ask me that later too. So I just want to leave you with a reminder that the culture around how you think about your products, how you introduce new products, how you improve products, and how you come up with new products, all of that really has its roots in engineering architecture. So an engineering solution can solve more than just problems that look like engineering problems. For us at Distillery, MLPipes has really elevated our culture of innovation, and it's particularly strengthened our culture around faster development and continuously improving, and it's really unlocked our innovation. Thank you.
Thank you, Melinda. Thank you, thank you.